All right, welcome back to the second tutorial. So, of course, in this tutorial, uh, what we're going to look at is the fundamentals of machine learning. If you haven't checked out the previous tutorial, do check it out. This is the continuation of it. So, if you haven't checked it out, this won't make much sense. So, we're still in the first tutorial or the first course, that is the fundamentals of machine learning. If we quickly look at what we've covered till now, we've covered the introduction to machine learning, the definition, the traditional versus the machine learning approach, and we also briefly looked into different types of ML systems, that is the supervised, unsupervised, semi-supervised, reinforcement learning, instance versus model-based learning. So the today's in this tutorial, what we are going to look at is the linear regression example. We'll train a linear model using the famous package scikit-learn, and in the next tutorial we'll check out the challenges of machine learning. All right, I hope you guys are excited as I am. Now if we quickly I've already opened up my Jupyter notebook where we have left in the previous tutorial. Now continuing on, I won't be coding it, however I'll be explaining it to you guys just to save some time. Right, I think this is the best and efficient way of doing it. I will be completely explaining it from A to Z so that you guys don't feel left out, but in the best interest of time, I won't be coding it. That's how it'll be. But however, a few crucial elements we'll definitely code it out, but this is just so you guys understand the what we're trying to do here and how the code is laid out. Just the basic example, but when it gets to the practicals, we're definitely going to code out. You don't have to worry about that. All right, so here what we are going to do is train a linear regression model on the data set. So the data set itself is called, we're taking it from GitHub, the course, right? So we will look into the data set itself. So what we're going to do now here is we're going to import a bunch of libraries, that is the matplotlib, .pyplot as plt, import numpy as np, pandas as pd, and the scikit-learn. From scikit-learn we're importing the specific method or function or called linear model, and we're also importing OS to handle a bunch of OS operations. So all right, so let's see the first line of code. We say data path equal to os.path.join datasets, comma livesat. So if we quickly take a look at this, so what this line of code does is that it creates something called as data path. Okay, I will run it and show it to you guys so that you guys understand it completely. So let's say if we run this right now, I'll just go ahead and run this. It says it's downloading, but if we quickly take a look at data path, it's created a path for us, with reference to the present working directory. Now if I quickly do pwd, you can see that with reference to this, the data path has created the path for dataset / livesat. So why do we need it? We need it because the dataset that we're going to download, we're going to put it inside that. So what we're essentially doing is we have the data in this URL. So what we're saying is with this URL, along with if you get into the dataset / livesat with the file name, that is this, right? So if we quickly take a look at it, so I'm just going to open a new tab, and then I'm going to put this, right? and then I'm going to also put this is the file name, right? So if we put that and run, you see it goes to that file where the data set exists, and all that we're doing is we're just downloading that data uh, with the URL library urllib.request.url retrieve from the URL and put it into the data path with the file name. So that's what this is doing. If you hit shift tab on this, you can see the URL along with the file name. So that's where it will put it. Here the file name can also be a complete directory itself. It does not have to be an exact file name. If you just put the file name, it will put it in the present working directory. However, we have just created a directory called dataset/livesat. So what it will essentially do is, if you say datasets/livesat/ the forward name, file name, it is going to put inside of that folder. So if you take a look at the datasets folder, it has created the livesat, and you can see it was just created about 2 minutes ago. So yeah, so that's how that is working. Now if we quickly take a look at the data set itself, right? So we've called it OECD. So it basically, so all that we're trying to do essentially, yeah, apologies. What we are trying to do is we are trying to, figure out the how satisfied people in certain countries are based on its GDP growth. So we're just trying to figure out if a person or people in a particular country are or more likely to be happy if the GDP of that country is high, and vice versa, right? If the GDP is low, what is the life satisfaction? So that is what we are trying to understand here, and we are trying to get some insights on it. So here we can see the y-axis is life satisfaction, and of course the dependent variable is the GDP, that is the x-axis. So we can see that there is a trend that is clearly it's showing some linearity, right? So more the GDP, the life satisfaction has definitely increased. So is it safe to say that if the GDP of the country is high, is the life satisfaction also high? Well, yes, this is what the model is saying to us, and if we, I mean, we've also plotted the graph, we can see that. So again, let me just so now that we've understood the downloading part, let me just complete the rest of it. So once we have downloaded, so we go into that folder uh, and then read that CSV using the pandas library. Of course, we know that. And then GDP per capita is another. So there are two different data sets that we are downloading, right? So and then we're going to group those data sets and then figure out how it looks. So that's what we're doing. Now these are the two different data sets that we have downloaded. Next is the prepare country stats. Now don't worry too much about this. This is just a pre-processing pipeline for this particular data set only. So if you take some other data set with completely different columns, this is definitely not going to work. So do keep in mind this is just for this data set, particular to this data set itself. This is just the pre-processing, don't worry about it. But this is what we're concerned. So we say prepare country stats, so we call it, and then we pass the data that we have used pd.readcsv to read it into the memory, and then we pass that. Now we get x and y. So if we quickly take a look at x, so it's just bunch of arrays, and y is its corresponding the life satisfaction, right? So how you can just imagine that x is the independent variable and y is the dependent variable. How is the life satisfaction increasing based on the GDP of that country? Yes, that's what we are doing now. So np.c np now if you just now np.c underscore what that does is it translates slice objects to concatenate along the second axis. So if we take a look at an example, Now we pass in two different arrays, right? So this is an np dot array of 1 to 3, and the second value is np dot array of 4 5 6. So what this does is it basically concatenates in different dimension. So that becomes 1 and 4, you can see 2 and 5, and 3 and 6. So they come together and they group up. So that's what is happening here. So now that we understood that, if we also look at country stats, so yeah, now here you guys can so all that we did here in the prepare country stat is basically we ended up getting a data frame that looks like this. So we have the country, and then we have the GDP per capita and its corresponding life satisfaction. So here if we take a look, we can see that Russia has GDP of 9054. This is of 2015. This is not the latest, so don't don't even think that this is the latest data. This is of 2015. So we have about the average life satisfaction of the people living in Russia, about 6. And you guys can understand, right? So we have the country, GDP, and life satisfaction. So we can index this data frame using the country, and that's what is happening as well. So that's where we get X. So what happens is, now if you take a look at this, right? Now this only gives the GDP per capita of that particular data set. So since it is indexed to country, so country is definitely going to show up. However, if we had not indexed it, here you can see that we are indexing the country, right? So if we had not indexed it, it wouldn't have been showing, but it's all right. We're just interested in this. Now if we say 0, it'll give us the actual value of it without the index, because we are absolutely indexing it instead of relative indexing. So yeah, that is what we're doing here. So we're saying that we're converting it to np.concatenate. So country stats GDP, so that is X, of course, and the life satisfaction is Y, and then we are plotting it, then taking from the sklearn, the linear model, we are instantiating the linear regression, and then we are fitting it on the X and Y. So the X being the independent variable, the Y being the dependent variable. So we're fitting the linear regression on that data set, and then here what we are doing is making a new prediction. So do keep in mind whatever the shape of X is. Now if I just X dot shape, so it's 29 by 1. Now if I say 0, oh sorry, I should not do X shape of 0, it's just X of 0. So it is just an array, right? So likewise, I've already shown you guys. So it's a 2-dimension array. That's why when you say shape, you get 29 comma 1. So 29 being the different countries, and 1 being the actual value itself. So that's why when you index it, you just have to say 0. Now you get the array version of it. So, and also when you make a new prediction, you need to pass in as 2-dimension itself. So, and then you can call predict on new, and you can see that if the if the X underscore new, that is the GDP per capita, if the value of GDP per capita is 22,587, what would be the life satisfaction? So it is printed out if we predict on that data, it is printed out 5.96. So we can have an estimate that if the GDP of the country happens to be about 22,587, then the life satisfaction would be somewhere around 6. So that is the inferencing. So you guys can see how easily and quickly we built. The only thing to keep in mind is the data pre-processing, but that is the inevitable aspect of machine learning. We always have to pre-process the data that we have, and sometimes it won't be as good as this. Also, you have to do a lot of pre-processing steps before you pass it to the model itself. So I hope you understood. Just to quickly reiterate, we're just downloading the data set, and then we're loading the data set using the pandas read CSV function and pointing it to the dataset directory, and then pre-processing it, and then we call that function that will pre-process the data, and then we convert it to arrays using concatenate, and then we visualize. We just have the plot function to visualize, and we are doing the scatter plot, x being the GDP per capita, y being life satisfaction, and we stick up a linear regression model, fit the model to the x and y, and then get a new data to predict on and make a prediction. So I hope you guys understood, and this was a bit interesting. Don't worry if you did not understand this. We are definitely going to go more in depth, but this should just give you the foundation and also the code that you can go through, and just understand if you're relatively new to Python and machine learning in general. All right, so next what we will do is do the challenges of ML, um, that I'll take up in the next tutorial. So stay tuned for that, and till then, take care. Thank you.